Well, good afternoon, everyone. Thank you for joining us here on the first day of VMworld 2014. It's good to see so many of you, even standing in the back there. My name is Simon Long. I work here at VMware. I'm a desktop architect in our OneCloud team. Previous to being in the OneCloud team, I worked in professional services over in Northern EMEA, where I worked with some of our largest VDI customers, and also helped them both optimize and troubleshoot some of their PCoIP issues as well. I'll let Tony introduce himself.
Great. Thanks, everyone. My name is Tony Nguyen. I'm a product line manager here at VMware. I've been at VMware for about 4 years now, so my team owns the remoting technologies, the things that take your virtual machine to your client endpoint. So that includes things such as display protocol, PCoIP, USB remoting, 3D graphics, and our choice of the Horizon clients. So if you have questions regarding any of those technologies, just let me know. We can discuss, any of the other things that, like other clients and such, afterwards. Okay. Cool. We can get started.
Okay. We'll just skip the disclaimer. I'm sure you'll all know this word for word by the end of the week. We've got a packed agenda. I'm not going to go through every single section for you. So we're going to kind of start off at a higher level, and then we're going to start kind of digging down into the weeds as we go through into the different sections. So I'll hand over to Tony to kick us off.
Great. So we're about 5 minutes in, and I'm going to do just a quick recap of end-user computing. Then we're going to go into the details as far as what we've been announcing, and some of the latest features and such that we introduced with Horizon 6. So late last year, our EVP Sanjay Poonen joined end-user computing from SAP, and Sanjay's done a very great job of reinvigorating of the end-user computing group at VMware. So under his leadership, basically we've reaccelerated the momentum, and he set forth on proceeding down and announcing a series of M&A activities and also strategic partners. Last fall, we acquired Destone, the leading provider of DAS, and we followed it up with a strategic announcement with Cisco, in which case they delivered Destone desktops on their cloud infrastructure. After that, basically, we did an announcement with Google whereby we allowed Google Chromebooks to connect to our VDI backend. So that was very important for our customers in the K1 through 12 sector. For those of you who still question whether VMware is really dedicated to the end-user computing space, earlier this year, VMware made the biggest acquisition in its history. We purchased AirWatch for $1.5 billion, and it's something that we're slowly integrating into our end-user computing space. Recently, we announced Horizon 6, and if that wasn't enough, we just announced last week that we acquired Cloud Volumes. So they provide real-time desktop app delivery on demand. So I mentioned previously, VMware has always historically been known as a data center company. Our hypervisors consider the foundation for a lot of the data centers, but what we're doing now is we're working with the Layer 1 team and leveraging a lot of the new solutions that they're building, things such as the software-defined data center and things such as the virtualized infrastructure for compute, storage, and networking, right? So basically, our team plays in the end-user computing space. We offer solutions for desktop, mobile endpoints, as well as content collaboration. Again, we feel that we have a unique position and basically we're uniquely positioned because we work very closely with them to basically integrate our products into their solutions and leverage them to provide a holistic solution. Examples of that. Our customers that want to leverage and already have VC Operations Manager can use VC Ops for View and thereby monitor and maintain their View desktops. So our vision for end-user computing is to basically provide a single unified workplace whereby it's going to allow our customers to work at the speed of life. And essentially, what that means is, think, for example, you start off working in the morning, you work on your desktop. Later on, you move to your laptop because you're moving between different conference rooms, and at the end of the day, basically, you go home and you're working on your mobile devices. Well, what we're striving for and what we're working to deliver is basically having all your apps, data, and content follow you wherever you are, whether it's on a mobile device or whether it's on your laptops. So This slide just shows that basically VMware plays in all these spaces, whether it's desktops, mobile devices, or content collaboration. And you're going to hear a couple of announcements where we're going to essentially be announcing a solution that integrates all this into one. I don't want to announce anything and spoil it for you guys tomorrow. So let's get into the details as far as what we did with Horizon 6 and View and PCoIP. So one of the keystone features that we delivered in Horizon 6 was our RDS solution. So whereas we always had a solution that allowed us to deliver virtual desktops before on top of our virtualized infrastructure, what we're doing now is integrating the RDS capability onto our virtualized platform. Most people don't know that we've already had support for RDS with View, but the key point there is it required you to use RDP, which customers did not want to do, in our opinion, right? So what we did was we worked with Microsoft hand in hand to implement a protocol provider interface. And what that protocol provider interface did was it allowed us to basically insert our graphics capability and insert our protocol into the RDS framework. After we did that, basically, it allows us to basically deliver RDS desktops and RDS apps using PCoIP for a rich user experience. Another benefit of going down this approach is that all the remoting technologies that we've been working on for the past 4 to 5 years for virtual desktops, we get to integrate and basically transport those over to basically RDS desktops and apps. So I mentioned RDS desktops and apps are one of our keystone features and capabilities in Horizon 6. So the platform itself is supported on Windows 2008, Windows 2012, and Windows 2012 R2. It can support up to 150 sessions each, and we have broad support for all the clients. So today we have support for Mac, Windows, but we also have support for iOS and Android endpoints. In Q3, in around the September timeframe, we're going to add support for Linux clients. So for you guys that have Linux clients and you want to access your RDS desktops, you can go ahead and do so with Linux clients. Another key thing that we did for this is basically we leveraged a lot of all the goodness that we developed previously with Fusion and Workstation to deliver a seamless experience when you use your apps on either Windows or on Mac clients. So this slide just shows that from the Horizon client, basically you can access not only your virtual desktops, but now you can access your RDS desktops and also your RDS apps. Another feature that we developed that was it's pretty nice is now basically when your client roams between different IP addresses or different networks, you can basically have your session persist or maintain. So imagine, if you will, you're working in your office and your laptop is docked, per se. What you can do is, if let's say the top of the hour rolls around and you need to move to another meeting room. So when you undock your laptop, what generally happens is that your IP address changes and basically you lose connectivity. Now what's going to happen is when you undock, it's automatically going to maintain your session because it's going to be able to use your Wi-Fi connectivity. You can go to your other room and basically just open your laptop and you're up and working without having to re-log in. So from a bandwidth enhancement perspective, we really work to basically optimize the bandwidth settings so that basically it provides a higher frame rate under congested and lossy networks. In this example, basically we set up a network with 5 megabits per second and 50 milliseconds of latency, not atypical of a WAN environment. So in this, on the left-hand side, what we did was we compared View 5.3 in the dark blue with Horizon 6.0 in the light blue. And what we got is we got a 24% frame rate improvement. The results were even better when we actually introduced a little bit of packet loss, 0.5% packet loss. What we saw there from View 5.3 to Horizon 6.0 is we actually got a 50% improvement in the frame rate. So where this helps out is basically, let's say you're either watching a video or basically some type of video on demand on a WAN link or on, let's say, a Wi-Fi network. You're going to see a dramatic improvement as far as the frame rates that you get for your video. So what we're showing here, let's see. Yeah. Okay, so we did a video to actually show you the visual effects and how the new enhancements actually improve the frame rate. So on the left-hand side, we set up a web page with a Silverlight demo, and we launched the computer management tool. We did the same thing on the right-hand side, but on the right-hand side, you have Horizon 6. And what you're going to see here is, looking at that computer management tool, you get an average frame rate improvement of over 150%. So this is going to, again, this is going to be applicable when you do web browsing, when you watch videos, and so on.
Just a key point on this is the GPO settings for PCoIP is actually the same, so we haven't made any optimizations for the new version of Horizon in this example. So they're just exactly the same. These are what you get just from the improvements we've made within the BAP.
So one of the biggest changes we made is we actually changed the default settings on PCoIP now, right? In View 5.0, our partner Teradici did a great job of delivering us a first-class protocol by implementing things such as an improvement in the lossless codec, implementing client-side caching, and enabling build to lossless. We were able to reduce the bandwidth by up to 75%, right? Since then, it's been a few years now, and we have customers deploying it, and they're giving us feedback saying, this is great, but can you help us improve the performance out of the box? So what they mean by that is, PCoIP, we've always taken the position that we should use up enough bandwidth to provide the best experience possible. But our customers are saying, let's find a balance whereby you still provide a good user experience, but you're still also bandwidth friendly. So we came back, we had an architectural summit with Teradici to determine what the new value should be, whereby we change the values, we provide bandwidth savings on one side, but we still have a good user experience, almost to the point where most users cannot tell the difference. So these are the three values that we've changed in View 5, or in Horizon 6 to View 5.3. The first of which is basically changing the build to lossless setting. So disable build to lossless being off means that the display protocol is going to build to a fully lossless image. And that is great for use cases such as a doctor viewing a medical record or x-ray, right? You want a picture-perfect image. However, in other use cases such as just using Office apps, Microsoft Word, maybe PowerPoint, Excel, you don't need that fully lossless image. So basically, turning off the lossless setting basically saves you significant bandwidth. The second setting that we changed was the maximum image initial quality, and we changed that from 90 to 80. And so what that setting does is basically it affects the compression level for pixelations in video, pictures, and whatnot. And by just tapering that down a little bit, we get significant bandwidth savings. We did the same thing for the minimum image quality, so that's more like for the baseline. Same thing. It affects the compression used when animation is taking place, right? So key thing for your customers, or for those of you who have a current deployment that are thinking about upgrading. If it's a net new deployment, meaning you've never deployed Horizon before, and you're deploying it for the first time, you're going to automatically get these settings. If you have a previous install, View 5.3 and previous, and then you upgrade to Horizon 6, but the catch is you never customize the PCoIP ADM template, meaning you use all the default values, you automatically can get the new settings. Now, if you have a previous deployment and you upgrade, but you did customize the PCoIP ADM template, things such as you want to preserve build to lossless, right? And you want to preserve some of the other customized settings that you previously configured. we're going to preserve those settings for you. So we'll be smart enough to know if you have a customized template, preserve that because you set it for a reason.
Just a key thing to point out here, Tony. On the second section there, where we've got no customization, obviously originally build to lossless was enabled. So if you're actually using build to lossless in your environment, you didn't actually have to configure that. But by upgrading these new settings, it will disable it. So if you actually require build to lossless in your environment, make sure once this is upgraded, go through and make sure it's enabled.
So this chart shows the bandwidth savings that we get. So on the left-hand side, basically we ran a login VSI for medium workload. And essentially, comparing View 5.3 to basically Horizon 6.0, you get 24% bandwidth savings. On the right-hand side, we did another test. We ran a 720p video. Same issue or same performance improvements. Basically, we got up to 32% bandwidth savings. So for most customers, you can expect between that range.
Cool. Thanks, Tony. Okay, so we're going to talk a little about optimizing the end user experience. And I've decided to kind of split this down into two separate sections. So first of all, we're going to look at optimizing your environment for PCoIP. And then once we've done that, we're going to go talk about optimizing PCoIP for your environment. So the first thing we want to do is we're going to look at networking, so specifically your wide area networks and your local area networks. Now, if we don't actually spend time in optimizing your networking, it doesn't matter what changes we make to the GPO itself. If your packets can't get from your virtual desktops to your end users without having packet loss or lots of latency, it's not really going to make any difference. So we need to start kind of at the ground level first. So these are a few of some of the high-level recommendations that we have to offer. So quality of service. Treat PCoIP similar to how we treat VoIP. It's a similar protocol, and it's a real-time protocol, uses UDP packets. So if you have VoIP in your environment, we wouldn't recommend putting PCoIP above it in a priority level, just slightly below it, because PCoIP could, in theory, affect your voice calls. But certainly place PCoIP in a priority level above any non-latency sensitive applications or any non-critical traffic such as file and print, so kind of in between that level. But certainly work with your network teams, understand what priority levels you already have, and make sure that PCoIP will get a high level priority but won't also interfere with anything that is more critical than what you think PCoIP should be. So congestion control is something that we kind of see quite often. I think typically out the box, when you configure a router, and when I say router, I mean router in American, tail drop is enabled, and tail drop is a bit of an ignorant way of kind of doing queue management. So on your router, if your queue gets full, tail drop will ultimately start dropping any packets that are coming into your router. So we would recommend, where possible, using wred, which is kind of a bit more of an intelligent way of doing congestion control. So as your packets are coming in, if your queue's full, it'll actually kind of look at the priority level and may actually decide that this packet is more of a priority in your lower level, and it'll start to kind of do more intelligent packet control. That's kind of a high level of what wred is. It's a bit more intelligent than that, but kind of these are the sort of things that we want you to start looking at. We also want you to minimize latency. PCoIP doesn't really handle a lot of latency too well. Typically, if we have a large amount of latency on the network, your end user will click kind of the start button, and there'll be a slight delay for the packets to get from your data center down to your endpoint. And when these delays start to happen, end users start to say, oh, my PC is getting slow, start making help desk calls. So we want to minimize the amount of latency we get. And kind of quite lately, a lot of our customers now are starting to kind of expand the VDI environments they have. Typically, when we first started out, it was more 1,000 users in one office. Now we're starting to see these remote locations, users working from home, and all these are getting further and further away from the data center. So we want to look to minimize any routing and any hops that you have in your network where it's possible. Every kind of piece of hardware your network traffic needs to go through is going to add in a layer of latency. So if we can reduce the amount of hops, then that will ultimately reduce some latency. We also want to try and avoid any intrusion detection systems, like when your network, if all your traffic's going through these, if it basically is going to start looking at your network and say, okay, is this a malicious packet going through? It's going to have to inspect every PCoIP packet that goes through. So if we can kind of whitelist these, if it's possible, you need to speak to your security teams, see if this is an option. Whitelisting this kind of traffic will certainly reduce a lot of the latency that we see from some of these devices. However, we kind of understand that maybe this is not always an option, but you can always let them know that the PCoIP traffic is actually encrypted. So we also need to be aware of the burstable internet connections. Now, quite often when we go to our ISPs and we say we'd like a 30 megabit pipe, and they come back and say, yep, we can do your 30 megabit pipe and we can burst you to 50 meg. And you think, great, free bandwidth. What we need to be aware of here is the committed information rate. So the committed information rate is a kind of guaranteed amount of bandwidth that your ISP will guarantee that that traffic will always flow. So between 0 and 30 megabit, that's what they class as the committed information rate. The kind of the buffer between the 30 megabit and the 50 megabit is kind of burstable capacity and is never guaranteed. So if you start getting contention on that internet connection, packets can be dropped at random. And obviously if your PCoIP traffic is getting dropped at random, your end users are going to start having issues where a lot of their screens aren't coming up in a timely fashion. So when you're sizing for PCoIP in your environments, only size to the committed information rate. That'll make sure that your traffic always has a good chance to get from A to B. So there's just a few high-level networking recommendations. If you just do a quick Google of PCoIP networking optimizations, there's a good document there which will talk about these in a lot more depth, and that also offers some other recommendations as well. So if you haven't looked at your network yet, you probably should have done already, but certainly give this document a good read, and hopefully it'll give you some good tips and things that you can work with your network team on this. So the next step is to understand your use cases. Now, typically in the VDI world, when I talk about use cases, we're often talking about what the applications the user uses, and then we kind of translate that into the size of the virtual machines. You know, task work is typically a kind of light VM with a single CPU, 2 gig of RAM. Then we have our power users, depending on the applications they're running, maybe slightly larger. But in the PC over IP world, we don't actually look at kind of the size of the virtual machines itself. What we focus on is more about what the end user is doing on the screen, actually in the display itself. So on the left-hand side there we have our task worker, and they've got service now open, and it's just kind of call center, they take the calls. They also have multiple tabs open, so they can go to other vendors' knowledge bases, go to the Google tab, kind of start Googling any issues they might have. And on the right-hand side, power user there, just sitting in a Word document, just doing their usual day-to-day documentation. And quite often what we see is the roles often get the reverse there. So what typically is a task worker from the resources of the virtual machine ends up being a power user from the resources required for PCoIP. So to avoid confusion, I've kind of just changed some names there. I ran out of imagination for some of those, so I do apologize, but typically a tab jumper is kind of, I'm very much a tab jumper, whereas I have multiple tabs open in Chrome, and I'm constantly flicking between the two. And word warrior is just someone actually doing their job, just sitting there typing away in a Word document. Okay, so use case criteria. What do we actually look at when we talk about what we're looking at on the screen? So some of the key things we want to look at. The main one we're looking at is the volume of screen change. How often does the screen change and how regularly does it change? And what kind of percentage of the screen changes at the time? So if we're looking at the word warrior, generally a static page, the only thing that's really changing is the actual character that they're typing in the screen at that time. So PCoIP only needs to send a small amount of pixels from the virtual desktop down to the endpoint to make that display on the screen, so very little bandwidth is used. If you're looking at the tab jumper, they take the call, and then they suddenly are, okay, we need to go to VMware's knowledge base. So they click on another tab. Every time they click on a different tab, pretty much changes the whole screen. That whole screen of change requires pixels to be sent from your virtual desktop down to your endpoint to show that whole change of screen. And that requires a lot more bandwidth than it would have done on the word warrior. So you can kind of see where we've got a task user type person, but because of the applications and how they're using it on the screen, it actually makes them more of a power user from resources. So we also need to be aware of pixel perfect. Obviously, Tony talked about that quite a lot in the previous section. Do your users require pixel perfect images? 9 times out of 10, they generally don't. They'll tell you they do, but they generally don't. They can get away with a slightly grainier picture. We kind of typically see pixel perfect images mostly in the kind of the medical industry, where they need to look at images of X-rays, those kind of things, where you really need to be able to see all the tiny little details. Videos as well. All users want videos, we all know that. But do they really need videos? And if they do need videos, what size of the video? Do they need full screen video, which is ultimately going to cause a lot more bandwidth? Or do they just need a kind of smaller video that's just going to be a video of someone talking rather than a video of a football match? And if they need video, do they actually need audio to go with it? And what quality of audio? These are things that we need to understand. And do we use VoIP in the environment? Skype calls, web calls, link calls? Do you need these applications to run in your virtual environment? If so, you need to be aware of these things, because that often require other areas that you need to kind of consider, and we'll come to that shortly around your endpoint selection. And 3D graphics as well. I'm going to touch on this a bit later on, but 3D graphics is something that's quite important. So, endpoint selection. I mean, certainly when I first started VDI, it was pretty straightforward. You had a PC, you installed the software client on it, you connected to your desktop, and that was your only option. But nowadays, we have zero clients, thin clients, thick clients, mobile clients. And there's a lot of customers are like, well, okay, how do we know which ones we should pick? You know, what should we do? Should we go zero clients so we don't have to manage an OS, or do we need to go thick clients because we've already got the hardware already there? Or our users want to be mobile as well. Maybe we should use a mobile client. There's so many options now, and a lot of people get confused on, you know, what should we use and when should we use it. So the problem we have is that not all of the endpoints that we have on offer all the features that VMware offer. So for example, RTAV, which is our real-time audio-video codec. I think we introduced that in version 5.2 of Vue, I think. Yeah. So what this does is it helps reduce the amount of bandwidth that is produced by a kind of a web call within your virtual desktop. So the amount of traffic that used to get sent when you're doing video calls from your endpoint to the data center used to be quite large, to the point where it has almost become unusable. So we've used some compression codecs to help reduce that. But as you can see there on the table, the only real option you've got if you want to use that compression codec is to use a soft client. So if you already have zero clients, this may not be an option to you. So by understanding the use cases and what your users need, it will actually kind of then convert into helping you understand what endpoints you can actually select for your environment. So I just want to touch on another point that Tony kind of briefly touched on earlier with RDS apps and RDS desktops that we introduced in Horizon 6. As you can see, the zero clients at the moment don't actually support RDS apps. So if you already have zero clients in your environment and you want to utilize RDS apps, the only way you can do that at the moment is to connect to an RDS desktop and then launch the RDS app within the desktop. It kind of defeats the object, really, but that is the option you have at the moment. So hopefully that will change soon, but I just wanted to kind of let you know that that's the situation at the moment. So the Teradici Apex card, key point, it's not a GPU. A lot of people get kind of confused and then they think it's a GPU. It's actually a hardware accelerator card that you install into your ESX hosts themselves. And typically when we'll see customers using this, and it's quite useful, if they say you already have your review environment, you've got a lot of virtual machines running on your hosts are kind of getting to like 80, 90% of contention. And then all of a sudden, your CEO decides that every month he wants to send out a video kind of telling everyone how well the business is done. So that month, every user gets an email with a video attached and everyone starts to play this video. Now, playing a video within PCoIP will actually kind of cause a lot of additional bandwidth. And with that additional bandwidth, it will actually cause a lot of additional CPU usage within the virtual machine because the PCoIP process will kind of require it to send a lot more data down to the endpoint. So if you had just one user doing it, you probably wouldn't notice it. But if you have 1,000 users doing it, or 10,000 users all kind of doing this thing at the same time, ultimately it's going to affect your ESXi host and probably make it to the point where it's over-contended. So you can install these into your host, and what these will do, it will actually offload the PCoIP service from the virtual machine itself, and it'll kind of offload it onto the hardware, so hopefully it'll allow your ESXi host to continue running. But another key point, which a lot of people kind of they don't quite understand it does not reduce the amount of bandwidth that you're going to be using. We have this discussion a lot. Well, you know, I've run out of bandwidth on the internet connection. That's fine. We'll just put an Apex card in, and everything will work. They soon realize that it doesn't actually work. So this is kind of when you would actually want to use the Apex card. So 3D graphics. Now this is a GPU. 3D graphics. VMware have two types of graphics offloading options when it comes to Vue and graphics. We have VSGA, which is Virtual Shared Graphics Acceleration, which is multiple VMs to a single GPU. And we also have VDJ, this Direct Graphics Acceleration, which is a kind of a one-to-one. You'd use VDJ when you want to use kind of the latest and greatest OpenGL and DirectX codec versions. VSGA doesn't support the latest versions, so you need to be aware of that. But one key thing to be aware of when you're using graphics, on high-level graphics within your virtual desktops, that this will really put a big burden on your network from a PCoIP traffic perspective. A couple of years ago, I don't know if you remember, we ran a kind of 3D gaming lab in the hands-on lab section area. I think it was downstairs then. And we were playing Counter-Strike at 1080p on one of our endpoints, and I think we saw towards between 13 and 14 megabits per second for one endpoint just from the PCoIP traffic that was created from that. So if you're looking to use the GPUs and you're looking to use multi-monitor 3D graphics, you will require a lot of bandwidth for PCoIP. May not work well over the WAN, so certainly do some testing before you kind of want to implement it across the board. So there's also another good document out there. So if you Google Horizon View 6 graphics, there's a good document out there that which talks about when you use VDDA, when you do VSGA, what the versions of codecs are supported for the VSGA, how to troubleshoot it, how to install it, all that good information that you can use to kind of set up a POC if that's something you want to look into. Okay, this is a little tip, and this is something that we're starting to see a lot more with customers lately is, I think by default now, a lot of the browsers that are out there, they automatically come with hardware acceleration, and it kind of, if it's available, enabled by default. And what this does is by ticking that box, it'll actually change the API that is used, because every time your browser tries to render something, it'll look to go off to see the hardware and get the hardware to render it. And obviously in a virtual world, unless you're using the graphics acceleration, you don't have the hardware on the back end to do this. And what we're finding is that it's actually causing a high amount of CPU load because the API is trying to call this hardware that's not actually there. So if you've got a view environment and not using graphics, just make sure that this tick box is not checked. Make sure it's disabled, and that will hopefully maybe stop you from having some of the issues that some of our customers have been having. Okay, so we've optimized our environment for PCoIP. That was quite straightforward. Now we're going to talk about optimizing PCoIP for your environment. So as always, in IT world, it's a balancing act. It's kind of similar to the whole risk and cost. Do I want to build a new data center, or it's going to cost too much? What happens if our primary data center goes down? Can we accept the risk? And it's a similar thing in PCoIP world. In a utopian world, we would want it somewhere in the middle there. Not a lot of bandwidth is required for a good user experience. But quite often what we'll see is, we need to use a lot of bandwidth, and we're only really giving the end user a kind of a mediocre experience. So we can actually use the PCoIP protocol to kind of do some tuning to maybe help end up in this situation. Low amount of bandwidth, often the end user a really good experience. But there is a good chance that that may not exist, and you may end up, depending on use cases, kind of stuck in this place. Unfortunately, that is the way it is. You can't really work miracles. There is only so much you can change within the PCoIP protocol. So let's just dig down into some of the changes. Now, just before I go into some of these, just want to kind of just say that I'm not recommending you use these values I've got on this. This is an example of some of the things that we look at to change when we're talking with our customers. So the GPOs there, these are the kind of the main ones that we would look at. We have the default values, what they are by default, some of the new values that we might change it to, and then kind of a little idea of what the effect on the end user experience may be, and also the effect on the network, because ultimately changing these settings is going to affect both your users and your network. So for example, build to lossless, currently it's now disabled. If you enable that, obviously it's going to give your users pixel perfect images, regardless if they need it or not. So every time the user changes a page in a browser, it's going to keep building that browser page in the background until it's a pixel perfect image. It will just constantly keep doing it. So make sure if your users need pixel perfect images, that's the only time you'll enable this. And if you do enable this, be aware that there's going to be a large increase in network traffic. It will make a big difference. Obviously, it will depend on how many users are doing it. If it's just one user, you might not notice it. But if you've got 100 users doing it, it's going to make a difference. So frames per second is another one we kind of touch on quite a lot. Out of the box, 30 frames per second. That's quite a lot of frames per second. We could drop it down to something like 12, and you may actually find that the actual end-user experience change is minimal, but it's ultimately going to depend on the video type that you're doing. If we use my example earlier where the CEO was just talking about how well the business is doing, 12 frames per second were probably more enough to just sit there and watch the guy talk. But if the users decide they want to watch a football match, then 12 frames per second may make it too jumpy to actually be able to follow the game. So you need to understand what your user is doing from the video side of things, but ultimately cutting down the amount of frames per second will reduce bandwidth on the network. And audio, I actually like to use a kind of car stereo analogy for this. Does your user require audio? If they do they need FM quality sound, like crisp and clear, or can we get away with AM quality radio? You can still hear everything on AM, just not as clear. reducing it down from 500 to 250 can ultimately save you a lot of the reduction in the network bandwidth and may save you money if you're sizing for your internet connections. So, figure out what actually end users will accept. And kind of before I hand back to Tony, the key point here is to test all this out before you roll it out to all your users. Because quite often we'll have customers that will say, oh, I'll just change it and we'll just put it out across the board, and then you get 1,000 help desk calls coming in. Well, I can't watch a video, it's too choppy. So best thing to do is, my recommendation is to try it out on yourself first. If it's not acceptable to you, there's a good chance it's not going to be acceptable for anyone else. But also, as I've kind of talked about before, everyone's use case is different. So the applications that you're using are going to be different to the applications that your help desk guys are using. So also maybe try and do a test of a subset of those guys before you start rolling out to the whole team or the whole company. So make sure you always test, because ultimately it's going to make a difference. So I'm not going to go through every single one of these, but just wanted to always kind of point out that every change you make is going to either affect your user or affect the amount of bandwidth you're going to need. So understand the changes you're making them and why they're making them. There's a lot of good information out on the internet about what a lot of these GPOs do. So make sure you don't just kind of go in and go, well, I'm just going to drop that, I'm going to drop that, I don't know what they do, but low has got to be better, right? It's going to save me money. It doesn't always matter. It may be the case it will save you money, but it may not save you a headache for all the users that are calling your help desk saying their PCs are too slow because they don't understand. Okay?
Great. So that was a great transition slide. So Simon outlined the benefits and the effects of basically the different tuning parameters versus the effects on network bandwidth, the user experience, audio quality, and whatnot. Today, how many of you would consider yourself very experienced as far as tuning PCoIP and optimizing it for your environment? So I see a handful of people, but I state simplify here because I want to make it as simple as possible as having a GUI, having a dial or a tab for each one of these values, and basically have you, the administrator, basically apply a profile or change these values using a GUI, and then basically testing it out and getting visual indications stating that this is how it affects the user experience, but also what effects it has on the network bandwidth and whatnot, right? From an optimization standpoint, we want to provide you guys the tool necessary so that basically when you configure the PCoIP ADM template for a particular user, if they transition from, let's say, your corporate network environment to a Starbucks Wi-Fi connection, right? They get a different profile, and that different profile is going to provide them the best experience possible based on things such as the network conditions, the types of devices that they connect from, or whatnot. The last one is application. We want to enable you as IT administrator basically to choose which profile gets applied when and where. Other customers, the power users, may want the option to be able to select which profile they use also. And in certain instances it makes sense. In other instances where you, the IT administrator, may not want them to do so, we'll give you those tools necessary. So today, the options you have when you deploy a system, basically you can leave all the settings the same and use the default profile, or you can customize the PCoIP ADM template, apply it to the OU, and then that automatically takes effect and it gets applied to all the VMs, right? So what about if you, let's say you connect from, the analogy I like to use is, in the VoIP world, when you make a voice over IP call inside the corporate LAN environment, it automatically knows to use the G711 codec. Uses 64 kilobits per second. However, if you're making a VoIP call and you're connecting from a wide area network, it automatically knows to switch and basically use the G729 codec, which only uses 8 kilobits per second, right? We want to build that type of level of intelligence and give the IT administrator the capability of determining what gets applied where. I mentioned previously also, the system should be intelligent enough to know what type of devices you connect from, so that when you're connecting from a mobile device, it gets a profile that's optimized for wireless connections. But if you're using if you're tethered to a LAN and you're on the corporate network, well, basically, jack up all the settings so that you get a better experience, right? So. For those of you who are either big bikers or racers or like automobiles, the analogy I like to use is basically a gear. when you're racing on the Tour de France, there are certain, I guess there's certain legs of the race where it's just flat out. So you want a gear that's going to be optimized so that you can go as fast as possible. However, if you're racing through the hills and you're climbing a hill, you want a different gear that's going to make it easy as possible for you to basically climb up that hill, right? So that's the comparison I make. That I ask. It's like, do you want one gear or do you want multiple gears? So what we're working on and we're prototyping right now, and I have to give credit where credit is due. This is something that Chuck Hursis and I have been talking about for a while. Chuck is now at cloud.com, but basically him and I are very gung-ho and really want to work on this and move it forward. So we want to give you guys a set of custom profiles or a set of predefined profiles, right? After you get that, you can use a rules engine that states, if I'm using this particular type of device, if I'm connecting from this type of network, if your user, the CEO, he gets this profile, and he always gets this profile. We want to build that level of intelligence into the tool and basically enable you, the IT administrator, to be able to apply it based on basically what you hope to achieve, basically bandwidth savings, best user experience possible, whatnot. So one of the things we're currently working on right now is a real-time tuner. So I talked about having a tool that basically allows you to tune the different PCoIP parameters, right? And when you tune it, basically, when you increase the max bandwidth or minimize it or change frames per second from 30 to 24, in real time you can get a visual indicator of the effects it has on the user, but also not only the visual effects, but the quantitative effects on the bandwidth use and whatnot, right? So that's what we're working on. So in this video, let's see. What we're showing here is a very early prototype. We're showing the video on the left-hand side, and we're showing the PCoIP session stat viewer on the right-hand side. And what that's showing is basically the bandwidth being used at the current setting. So if we move from fully lossless to, say, smooth, hit apply. And what I want you to key on is the effects on the network bandwidth being used. You're going to see it drop right away, right? But does it really have that much of a negative effect on the visual display and whatnot for your user?
This is quite a useful tool, actually. If going back to doing your testing before you roll out to your users, this makes things a little bit easier. You don't have to kind of set it in the GPO, log out, log back in again. You can just set it on the fly, and certainly make things a lot easier than it used to be.
Yeah. And the beauty of this is, it's not just about using, the tuner to basically, just try the different settings, right? We want to be able to make it useful for you. Export the settings into a profile, and then it allows you to customize your own profiles also. Right. So, how many of you think that this would be useful? Is this something? Okay. Okay.
Wow. We should get PMs in here.
Yeah. So that's a very early prototype, but it's one of the things we're looking for, right? That was only a slider, and that wasn't the real-time tuning application, right? This is just a sample to give you guys an idea of what we could do and some of the possibilities, right?
Yeah, I mean, I probably would say no, because they're just going to drag it to the right, aren't they? And it's just going to saturate your network. I would have done the same thing. I'd be like, I want everything, and it's just.
So
yeah.
the idea is to give you, the IT administrator, the control to allow them to do so if they want. Let's say they're the CEO, and basically they're saying, we want to do it, right? Are you really going to say no?
Okay, so key takeaways.
Yep. So we talked about Horizon 6, some of the latest enhancements with View and RDS and PCoIP. We focused on really improving the end user experience for things such as video and whatnot, increasing frames per second and focusing on the frame rate over the sharpness of the video, right? But we also wanted to and give credit where credit is due. I mean, Sean Bass was the one that made a lot of noise last year and said, basically, if you tune PCoIP, you can deploy over the WAN all fine, right? But out of the box, it's not ready. He doesn't consider it WAN ready. So we really took that to heart. We came back, we worked with Teradici, and we came back with a set of new defaults that what we believe is WAN ready, but also provides a great user experience.
Yep, and also remember, optimize your network first. Do PCoIP second. Make sure you get your network ready for this new traffic that's going to be on it. And then we can look to PCoIP and how we can actually make those changes. And also understand your use cases. What are your users doing on the screen, not what applications do they use, and how they interact on the screen. Each customer is going to be completely different. Even though they may be using the same application, they're going to use it in different ways. So understand your use cases, and then that will help you make your client choices easier. So some relevant sessions based on some of the information that we've kind of just talked about. I won't read them all out to you, but they're there if you want to catch up on some of the other sessions. If you really enjoyed this session so much and you want to hear it again, it's available on Wednesday. We'll be back Wednesday for this.
Yeah.
I'll just leave that on the screen for a little bit longer so you've got time to note that down or take pictures. Oh, still people taking pictures? And thank you. Thank you very much.